All right, guys, welcome back. This is going to be the second part of the 7.2 instructional video. And as always, if you haven't watched part one, please go back and watch part one. It's going to introduce the fundamental concept of 7.2, which is substitution, and so show you some introductory examples. If you don't watch that one first, you're probably going to be fairly confused with what we're doing here. But if you have, we are going to get into some more complex problems in regards to solving systems of equations with substitution. Specifically, we're going to focus on word problems here. So we're going to start with this one. Mr. Carter is planning a math competition because everyone loves math with all their heart. 193 students sign up to go. To transport the students, the school will be providing buses and minivans. There are 8 potential drivers. Each can drive either a bus or a minivan. The school bus seats 51 people each, and the minivans sit 8 people each. How many buses and minivans are needed? Okay. I would recommend pausing the video and trying to figure it out on your own. And notice I'm not requiring you to use substitution here. If you're one of those people who just likes to think through word problems, you like to just critically think through it and go, okay, this is true, this is true, this is true, which means this. That's okay. Check your work with mine. Our work will look different, but you'll get the right answer. Okay. However, I will show how to solve this via substitution. So again, I'm going to show this. Hopefully you've given it a shot now. You have an answer, whether you did it with substitution or just thinking it through. I'm going to show it with substitution. Why? Because substitution can work every time. Substitution gives you a process you can follow. Make sure you don't miss any of your information. It really can be a foolproof way to solve any of these systems of equations. Okay? So before I can before I can solve with substitution, I got to set up a system of equations. So let's back up. How do I know I'm setting up a system of equations? Well, I don't off the bat. I do because I've solved this problem before. But if I'm going into it blind, I don't know that I'm solving it with a system. No one's told me to solve it with a system. So I'm just going to I'm going to pretend like I haven't seen this before. I'm just going to look at what I see and try and answer the problem. So the first thing I need to identify is, what are we trying to do? What do we need to know? They need to know how many buses and how many minivans are needed to transport all these kids. How many kids are we looking to transport? 193. Okay? So let's start to think this through. How many buses and minivans are needed? Well, I don't know the number of buses and I don't know the number of minivans. So I could go ahead and give those some labels. Maybe I call the number of buses, you guys like X and Y, so we'll do X. Y will be the number of minivans. Could use B and V if I wanted to. So let's see what we're told. Well, we know 193 students are signed up to go, and I always like to start my word problems by seeing if I can identify some sort of total. And 193 sticks out to me. There are 193 students, and this is who we're trying to transport in these buses and minivans. We're trying to figure out an efficient way to get them there. So these 193 students are going to be transported in buses and minivans. So we have 193 total, but they're going to be split up into 2 parts. But if we add the 2 parts together, we get the total. So I'm going to put a plus sign there. What are the 2 parts these kids are split up into? Well, they're either riding buses, which we're saying is X, or they're riding minivans. And we don't know how many, but we do know for buses, I can fit 51 kids per bus. 51 kids can be fit per bus. So if I do 51 times X, I'm going to get the number of people who are riding in the bus. I had to get that together with the number of people in the minivan, and I should get the total 193. This equation's all about people. How are we dividing up the people? Well, 51 people can ride per bus, and we know their X is the number of buses. And minivans seat 8 people each. So I know 8 people can ride per minivan. Okay? And this is an equation resembling how the 193 students are split up. 51 per number of buses, 8 per number of minivans gives us our total of 193. But I can't just stop here. You see, if I set up this equation, unlike the problems we've solved in the past, where we set up an equation, we can't just go and solve it and get x equals blank and y equals blank. Why? Because we only have one equation, and that one equation has two variables. And as we've talked in the past, there's no amount of manipulation I can do to this equation to get x equals a number and or y just equals a number. Okay? Which is why in the previous problems we've done, we've used substitution. And it's why I say we need a system of equations. I need another equation here so that I can use graphing, or in this case substitution, so that I can figure out, or I can get my equations into one variable. So I need another equation. Well, what could that other equation be about? Well, let's look at the pieces of info again. I've used most of them, but the one I haven't talked about yet is the 8 potential drivers. I haven't really dug into that. Well, again, this somewhat looks like a total to me. Why? Because I have 8 people driving the bus in minivans. I have 8 total drivers. Well, how can these 8 drivers be split up? Well, some are going to be riding the buses and some are going to be driving the minivans. This is where my second equation comes from, and I have to have this second equation. Otherwise, I'm not going to be able to solve for the variables. I need 2 equations here. I need a system. Okay? I figured out that the 8, I needed to use that for the second equation because I hadn't used that piece of information yet. And I have to meet both criteria, right? I have 8 drivers. So I can't just somehow figure out how I can split up the 193 people into 10 different spots, 5 buses and 5 minivans, because I only have 8 drivers. I have this second criteria I have to meet. Okay? In other words, in formal equation terms, we got to make both of these equations true. I not only need to split up the 193 students, but I need to split them up in a way where we are only taking 8 vehicles. Okay, between buses and vans. We're only taking 8 because that's how many drivers I have. So let's go ahead and solve the system. Let's see what combination of number of buses and number of minivans fits our criteria of having 8 drivers and transporting all 193 students. Well, now that we have the equations, we know how to do this. We can just jump into the algebra. Now again, make this easy on yourself. Get the variable alone. Get the variable alone, that's the easiest. The 2 easiest to me look like this x and this y. I don't want to get the x and y in the above equation alone because they have coefficients, which means division and nasty fractions, most likely. Here though, if I just subtract y from both sides, I get x by itself. Could I also have gotten y by itself? Sure. Well, I chose x. And now we can do the substitution. By isolating a variable, I can now substitute 8 minus y in for x in the other equation. Okay? Why do I do this? Because now I'm going to have a 1 variable equation. 193 equals 51 times 8 minus y, right? The 51 is multiplied by the x, and if I plug in 8 minus y for x, then the 51 has to be multiplied by the 8 and the minus y. So make sure both get multiplied by it. And now I have a 1 variable equation and I can figure out what y is. If any of the steps in green and red don't look familiar, please go back and watch the 7.2 part 1 instructional video. So I do my multiplication. 51 times 8, that's going to be off the top of my head. I'll check it with a calculator. I believe it's 408, but always good to check. 51 times 8, 408, minus 51y, plus 8y. Want to get my variables by itself. I could have combined like terms first too. We'll do that here in a second. Probably better if I combine the like terms first, but again, we haven't done anything wrong. Okay. I'll do it in one step too. Go ahead and combine these like terms. Minus 43. And again, if you're struggling with any of the steps I'm doing now, That's more of a chapter 2 issue than a chapter 7 issue. So again, please schedule some time to meet with me or get help on solving one variable equations. Okay, I do all this work, and what I figure out is y equals 5. Y equals 5. Okay, what is y? Well, y is the number of minivans I need to take. So I need to take 5 minivans. But I still need to figure out how many buses I need to take. So what am I going to do? Well, I'm going to plug my y value back into one of my equations. Now again, we traditionally say, we cover this in the 7.1 or the 7.2 initial video, we like to plug back into either of our originals. But I do have a third option here, and I'm actually going to use that bottom green third option, where we manipulated one of our original equations and remade it, transformed it to look like this. Did we fundamentally change it? No, we didn't, but we changed how it looked. And by changing how it looked, not only did it help us solve the problem, but it's the easiest option to plug our data into. Because I can just go 8 minus 5 equals x, and I quickly see that x equals 3. Okay? Again, the reason I can do this is because it is a form, 8 minus 5 equals x is a form of one of my 2 original equations. So I really am plugging it back into one of my originals, just a version that looks a little different. If you don't feel comfortable doing that, knowing you want to plug it back into one of the 2 blue originals, you will get the same answer either way. And I get x equals 3. So my conclusion that I'm drawing, and it's always important to interpret our answers, is I need 3 buses and 5 minivans. And that will be the effective way, given my criteria of 193 students and 8 drivers, to transport them to this math competition. Again, how can I check my work? Plug 3 and 5 in for x and y respectively in both your original equations. Again, you could do that in a calculator. If you don't know how to do that, I can show you how to do that sometime. But make sure you check your work. We know that 3 plus 5 is going to give us 8, but triple check, make sure 51, I'll do it in a calculator right now, 51 times 3 and 8 times 5, make sure they both turn out to be, or that turns out to be 193. It does, produces a true math statement, and that's our problem. Again, if you figured this out a different way, if you logic through it differently, that's okay. But this is how we solve it with a system of equations. So we'll do one more real-world example together. A rectangle is 4 times longer than it is wide. The perimeter of the rectangle is 30. Find the dimensions of the rectangle, the length and the width. The length and the width. So again, try this on your own. Check your work with mine then. Okay, so we're going to solve this together. And as you well know from earlier problems, I love making pictures. Okay, whenever I can, I'm going to make a picture. And I know a rectangle is 4 times longer than it is wide. So I'm going to go ahead and draw a rectangle, give myself a visual. And when I read the statement 4 times longer than it is wide, that means my length is bigger than my width, right? It's 4 times as long than it is wide. Okay, so we got a little ratio going on there. That'll come into play later. So we have the length and the width. We also know the perimeter of the rectangle is 30. The perimeter of the rectangle is 30. We want to find the dimensions. Well, let's start with the perimeter of a rectangle because I think that's the easiest spot. To find the perimeter of a rectangle, we know we just add up all the sides. All right, length plus width and length plus width. Again, 2 L's and 2 W's. Why? Because we know opposite sides of a rectangle are identical. They are identical in their size. So if this left side is length, this right side will also be length. Same length. So we know this is our formula for perimeter, and we can now plug in some values. I know the perimeter is 30, and I could combine some terms here. Right? I have 2 L's and 2 W's. Then I have an equation. But again, this isn't good enough. I can't just solve this equation. Okay, I can't just solve this and end up with somehow isolate L in a way where I get L equals a number. I need another equation to substitute into it to be able to do that. So what information have we not used? Well, we used the perimeter was 30. Let's go back to that first statement. A rectangle is 4 times longer than it is wide. We need another equation, but how can I turn that statement into an equation? Well, this gets really tricky, and you kind of have to think critically about it. If the length is 4 times the width, that means the length is bigger than the width. I'll draw a little visual here. Maybe the length is up here, and the width is down here. The length is down here, or the width is down here, right? If we're saying the length is 4 times bigger than the width, and we turned it into a height competition, right? The length is going to be bigger. The length is up top, the width is down here. And we know the difference between the two, excuse me, the difference between the two is 4 times, right? The length is 4 times as big as the width. But we want to set up an equation. What's the fundamental root word of equation? Equal. So how do I get them to be equal? Well, to be equal, if we look at this visual, right, I need to close the gap, right? I want to take my width and have it be equal to my length if I want to set up an equation. Well, how do I get width from being down here to up here? Well, let's look at how we cover that difference. If the length is 4 times as big as the width, then for the width and the length to be equal, I need to multiply the width by 4. So how do I write that in equation format? L equals 4W. And you go, wait, Mr. Carter. It says 4 times longer than it is wide. Why are we not writing 4L equals W? Hear me out on this. Again, let me go back to that example. The length is bigger than the width. That's what this says. If you ignore the times, we see longer than it is wide. The length is the bigger one. So if you look at my hands in the bottom right corner of your screen, the length is bigger than the width. We want to write it as an equation, though. To get it as an equation, they need to be equal. They need to be equal, but they're not right now because the length is bigger than the width. How could I write them in equal terms? Well, what's the difference? The difference is the length is 4 times bigger than the width. But we don't want them to be bigger. We want to write it as an equation so they're equal. Well, if the length is 4 times bigger than the width, how do we get the width equal to the length? We multiply it by 4. That is why we have L equals 4W. If you do 4L times W, what you're saying is for these to be equal, I'm going to take the bigger quantity and I'm going to multiply it by 4, but that's not going to make them equal. That's going to make the length even bigger. And that's not what we want. Because we want to write an equation, we need the length and the width in an equal partnership. How do we get them there without compromising the integrity and just ignoring the fact that the length is bigger? We need to multiply the width by 4. Okay, so what we have here now is we have 2 equations, and not only do I have 2 equations, but already one of my variables is by itself, so I can jump straight to substituting. Let's put 4W in for L. When we do this, we get 30 equals 2 times 4W plus 2W, which simplifies down to be 30 equals 8W plus 2W. I don't need this little parenthesis here. Which leads me to 30 equals 10W, which means W equals 3. W equals 3. Well, if W equals 3, let's plug it back into one of my original. I get L equals 4 times 3. So L equals 12. And there I have the dimensions of my rectangle. My length is 12, my width is 3. Let's think about the problem. The rectangle is 4 times longer than it is wide. Well, that makes sense if my length is 12 and my width is 3. And that, again, provides further justification. You would not get that answer if you had 4L equals W. We need to have L equals 4W. So my length is 4 times as big as my width. We met that criteria. And we need the perimeter to be 30. Well, what we said is this length and width are 12 and 3 respectively. Add them all up. 12 times plus 3 is 15. Plus 12, 27. Plus 3 is 30. We've met our criteria. So hopefully this provides you some insight on some real-world solving with substitution. Good luck as you transition now into your practice.